Children, welcome back to mathematics class. Today we are going to start playing with numbers. Let's refresh our memory of factors and multiples. Factors and multiples is a useful skill in real life. Factoring is a way to divide something equally. Now, for example, for house shows dance competition, I want to create a rectangular pattern with 8 girls. I want to make them stand in one or more rows with equal number of girls in each row. Let us have a look at all the possible ways. Now first is single horizontal row with 8 girls as you can see in the picture. Second is 2 horizontal rows with 4 girls in each row. So here you can see that. Third is 4 horizontal rows with 2 girls in each row. So here you can see that. Fourth is 8 horizontal rows with 1 girl in each row. So here you can see that. Okay, here 1, 2, 4 and 8. Divide 8 exactly. So all these are factors of 8. Factor is a number which divides the given natural number exactly without leaving any remainder. Now let's write factors of 12. Now we know that 1 into 12 is 12, 2 into 6 is 12, 3 into 4 is 12. So the factors of 12 are 1, 2, 3, 4, 6 and 12. Now let's write factors of 18 also. Now we know 1 into 18 is 18, 2 into 9 is 18, 3 into 6 is 18. So the factors of 18 are 1, 2, 3, 6, 9 and 18. Now let's do some interesting facts about factors. Now first is 1 is a factor of every number. So here you can see 1 is a factor of 12, 1 is a factor of 18 also. Every number is a factor of itself. So here you can see 12 is a factor of 12 and 18 is a factor of 18. Third, the number of factors is finite. That is, we can count the number of factors. So here you can see factors of 12 are 6 in numbers. Fourth is every factor of a number is less than or equal to the number. So here you can see the highest factor is 12 which is equal to the number and all other factors are less than 12. Similarly here 18 is the highest factor which is equal to the number and all other factors are less than 18. Now let's find out common factors of 12 and 18. Now here you can see 1 is in both the numbers, 2 is in both the numbers, 3 is in both the numbers and 6 is in both the numbers. So the common factors are those factors which are there in both the numbers 12 and 18. So the common factors of 12 and 18 are 1, 2, 3 and 6. The other day I went to withdraw rupees 5,000. The following message was displayed on the ATM machine. This machine disburses money in multiples of 2,000. Now let's see whether I will be able to withdraw rupees 5,000. Now multiples of a number are obtained by multiplying it by natural numbers like 1, 2, 3, 4 and so on. So multiples of 2,000 are 2,000 into 1 equal to 2,000, 2,000 into 2 equal to 4,000, 2,000 into 3 equal to 6,000, 2,000 into 4 equal to 8,000 and so on. The list never stops. Now here you can see I can withdraw either 4,000 or 6,000 and not 5,000 because 5,000 is not a multiple of 2,000. Now let's write multiples of 4. Now writing multiples of 4 is like writing multiplication table of 4. So here we have 4, 8, 12, 16, 20, 24, 28, 32 and so on. Now let's write multiples of 5. So let's write multiplication table of 5. So it is 5, 10, 15, 20, 25, 30, 35 and so on. Now factors and multiples are correlated. The factors exactly divide its multiple. So here you can see 4 and 7 exactly divides 28, and multiples are obtained by multiplying the factors. So here if we multiply 4 by 7, we get 28. Now let's do some interesting facts about multiples. Now every number is a multiple of itself. So here you can see 4 is a multiple of 4, 5 is a multiple of 5. Second, the number of multiples of number is infinite. So here you can see the dots which shows that multiples are infinite. Every multiple of a number is greater than or equal to the number itself. So here you can see 4 is equal to the number and all other multiples are greater than 4. Here also 5 is the smallest multiple equal to the number and all other multiples are greater than 5. Now let's find out common multiples of 4 and 6. So first let's write multiplication table of 4 and 6. So here we have 4, 8, 12, 16, 20, 24, 28, 32, 36 and so on. Now multiples of 6, 6, 12, 18, 24, 30, 36, 42 and so on. Now first common multiple of 4 and 6 is 12. So I write here 12. Now the second common multiple we can get by multiplying 12 by 2, which is 24. So here you can see next common multiple is 24. Similarly, the next multiple will be 12 into 3, which is 36 and so on. So here you can see 36. Okay, now let's do types of numbers. Even numbers. All multiples of 2 are called even numbers. Even numbers are exactly divisible by 2. An even number ends in 0, 2, 4, 6, 8. For example, 28 is even number. 108 is even number. Or 214 and so on. Odd numbers. A number which is not a multiple of 2. Odd numbers are not exactly divisible by 2. Odd numbers end in 1, 3, 5, 7, etc. For example, 17, 23, 65, etc. All these are odd numbers. Perfect number. If the sum of all the factors is twice the number, it is called perfect number. Now, for example, now factors of 6 are 1, 2, 3, 6. Now, if we add all the factors of 6, we get 12, which is twice of 6. So, it is a perfect number. Let's take another example. Now factors of 28 are 1, 2, 4, 7, 14, 28. Now if I add all these factors, I get 56, which is 2 times 28. So 28 is also a perfect number. Prime number. A number which has only 2 factors, 1 and the number itself. For example, 2, 3, 5, 7, 11, 13, 17, 19 and so on. They do not come in any other numbers table. Composite numbers. A number having more than 2 factors. For example, 4, 6, 8. all these are composite numbers. Every composite number can be written as the product of prime factors. For example, now we know 60 is a composite number and we can write it as 2 into 30. Now 30 can further be written as 2 into 15 and 15 can be further written as 3 into 5. So 60 is a product of 2 into 2 into 3 into 5. The order of the prime numbers may vary. Coprime. Two natural numbers which have only one as the common factor are called coprimes. For example, 16 and 27. Now factors of 16 are 1, 2, 4, 8 and 16. And factors of 27 are 1, 3, 9 and 27. So here you can see 1 is the only common factor of 16 and 27. So 16 and 27 are coprimes. Next is twin primes. A pair of prime numbers whose difference is 2. For example, 3 and 5. Both are prime numbers and the difference between them is 2. 5 and 7. Or 11 and 13. So these are twin primes. Now let's do some questions from exercise 5.3. Now first is write common factors of 42, 63 and 105. So let's write factors of 42. So here we have 1, 2, 3, 6, then 6 sevens are, then 3 14s are, 2 21s are, and then 42. Next is factors of 63. So 1, 3, 7, then 7 9s are 63, then 3 21s are 63, and then 1 into 63 63. Then factors of 105. So here we have 1, 3, 5, 7, then 7 into 15 is 105, then 5 into 21, then 3 into 35, and then 1 into 105. Now let's see which factors are common, that is which factors are there in all the three numbers. So here you can see 1, then we have 3, then we have 7, then we have 21. So the common factors of 42, 63 and 105 are 1, 3, 7 and 21. Now next question is write first three common multiples of 3, 5 and 6. So let's write multiples of 3. So here we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33 and so on. Now multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40 and so on. Now multiples of 6 are 6, 12, 18, 24, 30, 36, 42 and so on. Now let's check which factors are common in these three numbers. So here you can see 30 is the first common multiple. So we write here 30. Now the second common multiple will be 30 into 2, which is 60. And the third common multiple will be 30 into 3, which is 90. So the common multiples are 30, 60 and 90. Now let's move to the next question. Express as the product of primes. First number is 945. So children, I hope you know how to find out prime factorization So let's find out. Here we write 945 and we start with the smallest prime number. So it will be exactly divisible by 3. So 3 3s are 3 1s are and then 3 5s are 15. Again it will be divisible by 3 and we will get 3 1s are then 0 then 3 5s are 15. Again it will be divisible by 3. So here we have 35. Then 5 7s are 35 then 7 1s are 7. So 945 is equal to 3 into 3 into 3 into 5 into 7. Let's do one more. 637. So let's find out the prime factorization. Now 637 is divisible by 7. So 7 9s are 63, 7 1s are 7. Again 91 is divisible by 7. So 7 13s are 91 and then 13 1s are 13. So 637 can be written as 7 into 7 into 13. Children, I hope you have understood all these concepts. Now you will be doing exercise 5.3, question number 1, first and fifth part, then question number 3, then question number 4, second, sixth and 12th part. Thank you.